Hey guys, welcome to the second video of stoichiometry calculation problems. In this video, I'm going to teach you how to find mass of substance in a chemical equation. So let's begin by looking at this problem. Iron pyrites FeS2 reacts with oxygen to form iron trioxide and sulfur dioxide. What mass of iron sulfide gives 500 grams of iron oxide? So as in any stoichiometry problem, we begin by writing a balanced chemical equation. And to write a balanced chemical equation, we need to identify the reactants and product involved in this chemical reaction. So let's look at the problem once again. Iron pyrites FeS2 reacts with oxygen. So this is a clear indication iron pyrites and oxygens are the reactant. Just make sure that oxygen has name ending with ZEN, and this is like one of the substance, one of the elements that name when you write in the chemical equation, you write them in diatomic form. And it forms iron trioxide and sulfur dioxide. Clearly, these are the products. So let's write down a skeleton equation where you just put the formulas correctly on reactant side and product side. And we're going to follow heat and trial method to balance this chemical equation. And when you do that, you end up with 4 FeS2, 11 O2, 2 Fe2O3, 8 SO2. Here is the balanced chemical equation. Now, then you have to write a mole ratio for this chemical equation. And we put four substances. By writing the coefficient in front of it in a balanced chemical equation, you get the mole ratio of substances in this chemical equation. Now, the third step, we have to use molar mass to change moles to mass or mass to moles. So you have to find molar mass of all the substances involved in this chemical equation. Let's see, how do you do that? To do that, we have to use the periodic table, and you find the mass of individual elements in a substance looking at the periodic table. Then let's find out the molar mass. Let's look at one example up here. So molar mass of FeS2, as we have one iron, so you multiply mass of iron 58.9 by iron. Then we've got two sulfur, which is 2, and the mass of sulfur from the periodic table is 32.1. And do the math, you'll end up with 123.1 grams per mole. So mass of 1 mole of iron sulfide is 123.1 grams. So you can follow same strategy to find molar mass of all of these substances: oxygen, iron oxide, and sulfur dioxide. So once you have molar mass, the next step is you have to use the mole ratio and dimension analysis to calculate unknown mass, as the goal in this question is to find out the mass of iron sulfide required to produce 500 grams of iron oxide. So we know the mass of iron oxide, so we'll begin with iron oxide. And we know the molar mass of iron oxide is 168 grams. So 1 mole of iron oxide is equivalent to 165.8 grams. So let's put them in the order so that grams of iron oxide and grams of iron oxide can be cancelled out, numerator, denominator. And then our goal is to identify or calculate the number of grams of FeS2. So the next step, from the chemical equation, we know that 2 moles of iron will be produced by 4 moles of iron sulfide. So we put them in the order from the equation. And we also have the molar mass of iron sulfide, which is 123 grams per mole. So when you see this one, these numbers will cancel out, right? So you can cancel all numerator, denominator. And after that, place all the numerators on up here. So 500, 1, 4, and 123. I should have a parenthesis here. And all denominators, 165.8, 2, and 1 goes here. Then do the math, and you end up with 741.85. And as we say, we decided to use one decimal place. So 741.9 grams of iron sulfide. So basically, to produce 500 grams of iron oxide, we need 748 grams of iron sulfide.